In this first module, we are going to cover the basic concepts of energy, what it is, and the various forms of energy. Let's begin with the first concept. What is energy? In physics, energy is the capacity to do work. Work means able to do something to achieve a purpose. Over the past centuries, this understanding of the relationship between work and energy has led to many inventions. We use wind energy for wind turbines, electrical energy from chemicals in mobile device batteries, and water energy for hydroelectric dams. There are different forms of energy, such as light, thermal, sound, chemical, electrical, kinetic, and potential energy. In this course, we want to focus our attention on kinetic energy and potential energy. All moving objects have kinetic energy. The waves have kinetic energy. The wind has kinetic energy. And kinetic energy can be used to do work. As the wind turns the propeller-like blades of a turbine around a rotor, the turning force of the wind transfers energy to the rotor. The rotor causes a generator to spin and creates electricity that is used to power up cities. Here we see an example of kinetic energy converting to electricity to do work. Energy that is stored is known as potential energy. There are different forms of potential energy. Here we shall examine the following: chemical potential energy, elastic potential energy, and gravitational potential energy. Plants absorb solar energy from the sun and convert to chemical potential energy. When we consume food, our body absorbs the nutrients and stores the chemical potential energy. The chemical potential energy is converted to kinetic energy when we move our bodies. Petroleum is a type of fossil fuel that traps energy, first originating from the sun that was captured in ancient oceans. When the petrol burns in a car engine, the combustion causes the chemical energy in the petrol to be converted into heat. The heat is converted into kinetic energy that moves the car. Let's look at another type of potential energy. When you exert a force to compress or stretch a spring, it gains energy, and the energy is called elastic potential energy. When you release the spring, the elastic potential energy is converted to kinetic energy. That kinetic energy causes the spring to spring back to its neutral position. Likewise, when you compress a sponge, elastic potential energy is stored in the sponge. When you release the sponge, that stored potential energy is converted to kinetic energy, and that kinetic energy causes the sponge to spring back to its neutral position. Gravitational potential energy is the energy an object has due to its position above the ground. It is the result of the force of gravity pulling the object towards the ground. When we lift an object, we exert an upward force to overcome the downward force of gravity. We know that if a book is dropped on our feet from a short distance above the ground, we do not feel much pain. However, if the same book is dropped from a much higher position, the pain felt by our feet will be much greater. This shows that when the book is raised to a higher position, it gains more gravitational potential energy. In this slide, the force exerted by the weightlifter transfers energy from him to the weights. When he releases the weights, the gravitational potential energy of the weights are converted to kinetic energy as the weights drop to the ground. When the girl exerts a force to throw the ball up, the ball gains kinetic energy. As the ball moves up, the kinetic energy is converted to gravitational potential energy. When the ball starts to fall back to the ground, the gravitational potential energy is converted back to kinetic energy. From the examples we have seen thus far, you have noticed that when a force is exerted on an object, there is a transfer of energy to the object. The object gains energy. We will see in the next lesson that this force is in effect doing work when energy is transferred. The second important thing to note is that potential energy can be converted to kinetic energy and vice versa. And finally, We will conclude this lesson taking note of this very important principle of energy conservation. That is, energy cannot be created nor destroyed. It can be converted from one form to another or transferred from one body to another, but the total amount remains constant. We will learn more about energy conservation in the next lesson.